Good morning, students. So, in previous lecture, whatever lectures we have uploaded on the Google Classroom, in that we have discussed about the combustion in SI engine. Okay, different injection systems in the SI engine, right? So, and different uh, types of combustion chambers that are used in the SI engine that already we have covered. Now, today let us see what are the different stages of combustion in CI engine. Okay, after that we will cover what are the types of combustion chambers that are used in the CI engine. Okay, so before starting this, so let us discuss about this particular stages of combustion in CI engine first. Okay, so actually we have to remember this in this stages of combustion in a CI engine. Okay, we have to consider the two types of processes while discussing the stages of combustion in CI engine. First process that is called as physical process, and second is the chemical process. So what is this exactly? Let us discuss about this first. What is exactly happening in this particular combustion? Let us discuss about this first. So look at this. These are the two main important processes that are important while discussing the combustion in CI. So what are that? So first is a physical process. Okay, so what is the physical process here? So oil is injected into the combustion chamber, that is diesel is injected into the combustion chamber. The oil jet is atomized to droplets undergo vaporization, vapors are mixed with hot air, and combustible mixture is formed. So this particular process is called as physical process. So some amount of time is definitely required to happen this particular physical process. And second is called chemical process. So what is this chemical process? Low temperature oxidation of hydrocarbons and alkyl peroxy radicals formation, cold flames, blue flames, and hot flames. So to generate these particular type of these particular flames, we can say fully to develop fully that flame is required some amount of time. So some amount of time is required for physical process, and some amount of time is required to for the chemical processes. Okay, so now let us discuss what are the different stages of combustion in CI. Okay, just one second. So basically there are four stages of combustion in CI engine. We in SI engine we have discussed that there were only three stages of the combustion in SI engine, but here one more stage is added. Okay, so what are that stages? So first is ignition delay period. Okay, now what is this ignition delay period? We have already discussed that physical process and chemical process. So to perform that two processes, some amount of time is required, and that is nothing but your ignition delay period. Okay, now after completion of this ignition delay period and actual burning takes place, there is one second stage that is called as a rapid combustion, or it is also called as uncontrollable combustion. Okay, uncontrolled combustion or uncontrollable combustion. So that is the second stage. Third stage is controlled combustion. Okay, and last stage is after burning. Now let us see in the graph where these particular stages are. So here if you see at the starting, okay, here the point number 1 is given here. So from this point, let us consider this is point A and this is point B. So what is this point A? The start of injection of the diesel takes place inside the combustion chamber during compression some degree before TDC. Okay, but start of injection has been takes place, but there is no start of combustion at point A exactly itself. So why? Due to the physical process and chemical process, the combustible mixture must be formed inside the combustion chamber. Unless and until the mixture is formed, that will not get burned. And here if you see, the start of combustion is actually at point this particular point B. So some amount of rotation of this particular crank, okay, there is some difference between these 2 points, and that particular difference is called as ignition delay period. Okay, that means injection has been already started but combustion has not started. So that particular delay or that particular time period is called as ignition delay period. Okay. Now, next stage is called as uncontrolled combustion or rapid combustion. Why? Because at this particular point number 2, that is at start of combustion, the combustion rapidly takes place because the whatever combustible mixture is available inside the combustion chamber, that is very favorable for the combustion, and that's why the sudden rise in pressure takes place in that particular case, and that is uncontrollable. Okay. Or it is also called as a rapid combustion. Sudden rise in pressure takes place, okay, and it reaches at up to the maximum pressure. Okay. So at point 2 we'll get the maximum pressure inside the combustion chamber, around 80 or more than 80 bar pressure we will find in the combustion chamber. Now after that there is a controlled combustion. Why it is called controlled combustion? Because the start of injection has now ended at this particular point, and this we can control with the help of our injector. Okay, that's why this particular process is called as controlled combustion. So for this particular point number 3, if you see here, this is called as controlled combustion. And after this point number 4, okay, that is after point number 3, you will get the afterburning. Whatever unburned carbons are remaining at the end, that will get burned. Okay, after, and that process is called as after burning. Okay. So, or here again there is one more thing, that is motoring, that is non-firing. Unburned hydrocarbons are available there, but they are not yet burned. Okay, that is called as a motoring effect, right? So these are the 4 stages. Now let us discuss in detail about these particular processes. So what is ignition delay period? Ignition delay, that is generally 0.7 to 3 millisecond period, is counted from the start of injection to the point where the pressure time curve separates from the compression curve, indicated as start of combustion. The delay period in the CI engine influences both engine design and performance. Now it affects combustion rate, knocking, engine starting ability, the presence of smoke in the combustion exhaust. Okay. Now ignition delay period, as already we have discussed, that it is converted into 2 parts. Okay. So let us discuss about this in detail. So point A, if you see here, this is point number A. Okay. So represents the time of injection, that is at this particular point we have injected the diesel. Okay, this A point is called start of injection. Point B is called start of combustion. Okay, represents the time at which the pressure curve first separates from the compression curve. Okay, so here again this particular point is divided into 2 categories. The ignition delay period can be divided into 2 parts, if you see. So first is physical delay and second is chemical delay. Why physical delay? So to happen the physical process that already we have discussed at the starting of this video. So that are the physical delays, and chemical delay means what? The chemical process which will be takes place inside the combustion chamber. Some time is required for that, and that is called as chemical delay. Okay, now what is physical delay? Just 1 second. So this is okay, the due to physical process and due to chemical processes, this particular 2 types of delays are occur. So the physical delay is the time between the beginning of the injection and attainment of chemical reaction. So during this period what happens? The fuel is atomized, vaporized, mixed with air, raised to its self ignition temperature. Okay, so this particular takes place during the physical delay. The physical delay depends upon the type of fuel. For light fuel the physical delay is small. For heavy viscous fuel the physical delay is high. Injection pressure, the physical delay is greatly reduced by using high injection pressures. Okay. Combustion chamber temperatures and turbulence to facilitate breakup of the jet and improving evaporation. Okay. Now what is the chemical delay here? During the chemical delay, reaction starts slowly and then accelerated ignition taking place. Okay. Generally the chemical delay is larger than the physical delay. Now this chemical delay depends upon what? The temperature of the surroundings. At high temperature the chemical reactions are faster. In most changes the ignition lag is shorter than the duration of the injection. Okay. Now many design and operating factors affect the delay period, and this is the main point. Remember, this is the main point that we have to discuss afterwards also, that is effects of knocking or effect of detonation which will be takes place in the CI engine, and what are the different factors affecting on that. Okay, that we will discuss later. But here you have to remember that whatever factors are affecting on this delay period, same factors will be affecting on the uh, uh, detonation. Okay, remember this. So first is Citian number, ignition timing, compression ratio, engine speed, output, atomization of the fuel and duration of the injection, quality of the fuel used, intake temperature and intake pressure. Okay, so these are the different factors that will affect on this ignition delay period. Okay, remember this. Now let us see some examples what exactly happens due to these particular factors on the delay period. So here if you see, on the y-axis there is ignition delay, on x-axis there is brake main effective pressure. Okay. So on x-axis pressure is indicated and on y-axis ignition delay periods are indicated. Now let us consider about the C10. Cn is what? C10 number. So if the C10 number increases, if you see here, here C10 number is 30, here C10 number is 39 and here C10 number is 52. So when C10 number is very much low, you can see here the ignition delay is very much higher. Now if the C10 number is increased, the ignition delay period is also decreased. Here for C10 number 52, the ignition delay period is very much less. Okay, so as C10 number increases, the C10 number ignition delay period decreases. Remember. Second parameter here, naturally aspirated or boosted. Okay, so if you see these particular dots, okay, empty dots, so this indicates that naturally aspirated, and here we can see this dark dots, that is naturally forcefully some amount of air is circulated inside the combustion chamber. Okay, so here in this particular case we get the less ignition delay period. Now here if you see again uh, for temperature, so if the temperature is 25 degrees Celsius and here temperature is 66 degrees Celsius, you will find that there is a decrease in ignition delay period. So if you increase the temperature of the air inside the or the inlet temperature of the air, then you will find that there is a less amount of ignition delay period. Okay, remember this. Now let us discuss the second stage, period of rapid combustion, that is second stage. The period of rapid combustion, also called as uncontrolled combustion, is that phase in which the pressure rises very high. The period of rapid combustion is counted from the beginning of the combustion to the point of maximum pressure on the indicator diagram. Okay, so this much. Now period of controlled combustion, what is by controlled combustion? The temperature and pressure in the second stage is already quite high. Hence, the fuel droplets injected during the second stage burn faster with reduced ignition delay as soon as they find the necessary oxygen, and any further pressure rise is controlled by the injection rate. Okay. The period of controlled combustion is assumed to the end of maximum cycle temperature. And the last stage, that is period of afterburning, combustion does not cause with the completion of the injection process. The unburned hydrocarbons, partially burnt fuel particles left in the combustion chamber, start burning as soon as they come in contact with the oxygen. This process continues for a certain duration called the afterburning period. Okay. Now the period of afterburning, usually this period starts from the point of maximum cycle temperature and continues over a part of the expansion stroke. The rate of afterburning depends upon the velocity of diffusion and turbulent mixing of the unburned and partially burned fuel with the air. The duration of the afterburning phase may correspond to 70 to 80 degrees of the crank travel on the TDC. Okay, so remember, this is the afterburning. Now if you see this block diagram, here you can find all whatever process we have discussed here. Okay, so this is physical delay, this is the chemical delay, and this is called as first stage, that is delay period. Okay, this is final combustion and this is products. So this is actually the combustion, okay, sequence of the events that are entirely occurring in the combustion process. So physical delay means what? Disintegration of the steam of the injection fuel, mixing of liquid fuels with air, vaporization, mixing of the fuel vapor with air. Okay, chemical delay means pre-flame oxidation of fuel, local ignition, and this fuel combustion inflammation, thermal decomposition and oxidation of the fuel air mixture. Okay, so here mixture of products of the partial oxidation or the thermal decomposition with the air. Okay, So these are the actually process that we have shown here. You see this, and this is the total